All right, guys, welcome to Lesson 5 Concept Development video. Big thank you to Emma, Colby, Emily Ann, Lily, Elliot, Anthony, and Ethan for joining me yesterday during the Zoom open session. I had fun with you working on some of the skills that we're going to be practicing today. So hopefully you got a little bit of a head start because we got together yesterday. I plan on sending you some Classcraft XP for joining us. I just haven't opened up Classcraft yet this morning. I have you on a sticky note. So I've also made a few mistakes in the problem set. So another shout out to Brooke and Emma for finding those mistakes and sharing them with me. I really appreciate those opportunities where you share those mistakes with me so I can be better for it. It is super frustrating on my end to make mistakes as a teacher for you or as a person anyways. But I do appreciate when I do make mistakes that people help me recognize those so that I can be better for them as much as it's frustrating to make them. So remember to keep that growth mindset. Use those mistakes as learning moments so you can move forward. So today we're going to be working on multi-digit multiplication, and we're going to be using the tape diagram and the area model to help us shift into the standard algorithm. So let's go ahead and start practicing some math problems. So we're going to first start with 21 times 5. And the first one we're going to do is we're going to use the tape diagram to help us with this expression. Well, we could think of this as 21 groups of fives or even 21 fives, right? So there's multiple ways to think of it. But if we think about it like this, 21 fives, well, our tape diagram should have, I'm not going to draw 21 of them. I'm just going to pretend, I'm going to do these dot, 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 and then show the last group as a 5. What this signifies right here in the middle is that there's a lot of these groups. Well, how do we show how many there are? Well, we just show with a little tape diagram representation that there's 25 fives in this tape diagram. So it just lets us visualize what we're working with. So if we were to do that, could we transfer this information into a tape diagram? Oops, sorry, into an area model. And well, absolutely. We're going to do a vertical kind of area model instead of a horizontal tape diagram. And we're going to take that 21 and we're going to break that 21 into easy to work with. Well, 21 can easily break into 20 and 1, right? So we're going to put 20 on the bottom and 1 up the top. Our 5 is going to go at the top of our area model, and then we can break this apart. So this is length times width because we're talking area model. So 1 times 5, well, that is 5. 20 times 5 or 2 times 5 is 10. Well, we're 2 tens times 5, so it would be 100, right? Oops, I should have wrote the math problem in here. And then we would just stack and add those. Well, I can do that one in my head, right? That's just 105. Okay, so really we're going to be focusing on the area model on the next problem. So in the problem set, when they ask for a tape diagram, if you can just show me the area model and the standard algorithm, that's really all I need you to show me. So just focus on those two pieces because I think that's going to help you move forward. Whoops, I didn't mean to do that. Let's clear the page. And let's try another one, but this time we're going to go straight into the area model. And let's try 2-digit times 2-digit now. So we're going to take 23 times 31. So if we were to write, that's the expression horizontally, but if we were going to set it up for standard algorithm, we would write it like this. So go ahead on your piece of paper, have that written in standard algorithm off to the side. And then let's go ahead on to the right or to the left, whatever's easiest on your paper. Off to the side, let's set up the vertical area model. Now, when we were working on an area model and standard algorithm at the same time, we're going to decompose the bottom number, the bottom factor. So we could decompose that as into tens and ones. And 31 would break into 3 tens and 1 1. So we're going to represent, I'm going to just take that away because I don't want that cluttering up my standard algorithm. I was just doing that so you could visualize it with me. So I'm going to put that 31 broken down into tens and ones over on the left-hand side of my area model. You can visually see that my tens place is larger than my ones place, which makes sense. Tens are larger than ones. And then in fourth grade, we also broke the top number apart and had 4 windows. In fifth grade, we're going to just leave it as one whole number. And this is where we're using the strategies from the last couple days to help us solve this. Well, this box is going to be 1 times 23, and this box is going to be 30 times 23. Now, for those people that were with me, I challenge you to pause anytime you see a math problem that I put up and complete the problem without me. See how far you can get without clunking. Press play, speed through it to see where you made the mistake or to see if you're correct, and keep moving forward like that. Challenge yourself. So in that first box in my area model, the top box, 1 times 23 is 23. Now, on the bottom box, 30 times 23. Well, I really can't do that in my head, but I could change it to 3 tens times 23 just to make my life easier. And that would be 23 3 times. If you need to stack that, you can. 3 times 2 is 6. Well, that would be 69 tens. Well, 69 tens is going to be 690. Well, 690, we'd have to stack and add them to get our overall product. These right now in our area model are just partial products. This is our products for the tens. This is our products for the ones. We need to add them back together so that we can see what the overall product is, and that's 713. Now, let's go look at the standard algorithm and follow those steps into the standard algorithm side. Well, the first box that we worked with was 1 times 23. Well, over on the standard algorithm, I'm going to just show you with the highlighter. We first do 1 times 3, and then let me change my color, and then we do 1 times 2. So I'm going to take those highlighters away so I can actually do the work. And so if I did 1 times 3, it's 3. And then if I did this, 1 times 2, it's 2. Now what you'll notice is our partial products, the 1 times 23 over here, is exactly the same thing we did up in the area model over to the right. Well, once we were done multiplying by the ones on the area model, where did we go? Well, we went to the tens place. So then we started working on the tens. Well, guess what? Over here is our tens place on the standard algorithm. But when we go to the tens, what did we have to do with that unit? We represented it with a 0 at the end. So we start that on the standard algorithm. We go ahead and place that 0 so that we start putting our answer right into the tens place with standard algorithm. This is your number one made mistake by students when they're first learning multi-digit multiplication. So please try to be aware of that. When you move into the tens place, we have to represent that with a 0 so we can start placing our product right into the tens. So now that we can do that, now we can do 3 times 23, but first we'll do 3 times 3, which is, whoops, I didn't mean to do that. Sorry, guys. 3 times 3 is 9. And then 3 times 2 hundreds is 600s. So then we're going to do 2 plus 9 is 11. And 6 plus 1 is 7. Now, again, we can notice the partial products for the tens places also exactly the same. But what you'll notice is the standard algorithm side is a little bit more efficient, a little bit faster to do it. One of those reasons is it already stacks your partial products perfectly for you. So let's go ahead and do one more with the area model. This time we'll do it step by step. We'll do one step over in the area model and then another step on the standard algorithm. And then we will move into just trying standard algorithm. And then I'll move you on to your problem set. So let's do another 2. Well, actually, let's bump it up. Let's do a 3-digit times a 2-digit this time. Let's do 343 times 21. Well, that's the expression horizontally. We can't solve it that way. So let's go ahead and restack it standard algorithm over here. But let's also create ourselves an area model off to the side. Now, I'm going to use the highlighter, so you don't need to do this. I'm just doing it so you can visualize it. We're going to decompose the 21. We're going to break it apart into the tens and ones. Well, breaking up 21, well, there's 2 tens and there's 1 1. So now I've set up my area model with the first factor, and I'm going to go ahead and place my other factor on the top. I'm going to go ahead and represent what these math problems are going to be inside of each part of the area model, because it's just length times width, right? This could also be represented as 2 tens times 343, which I think you could actually do 2 times 343 because there's no regrouping in your head. Well, what I mean by that is if I multiply this by 2, well, the 3 would double, the 4 would double, and the 3 would double. We should be having 686. Well, if you have 686 tens, we go ahead and place that 0 behind it. I should have actually started in the ones. Oh, Mr. Briggs, you said we were going to do this all at the. I messed up. I said that we're going to do it step by step, and I didn't. Now we have done the whole area model. Stack it and add it. I guess we'll do it on the next one. I have 7,203. I hope that's right. I'm going to check it over on my standard algorithm side. So the first step is to do ones times the top number. Well, 1 times 3 is, let me get 3. 1 times 4 is 4. 1 times 3 is 3. Well, that just so happens to be perfect, so I know I'm on the right track so far. Now I'm into the tens place. I'm multiplying 2 tens, so I'm going to represent that 0 there so I can start in the tens place. Number one mistake people make is not remembering to place that 0 for the tens place. 2 times 3 is 6. 2 times 4 is 8. 2 times 3 is 6. 6,860. So these two partial products are absolutely perfectly right. Let's see if I stacked and added correctly. 7,203. Perfect. All right. Let's actually do this one step by step. So 231 times 32. Let's restack it. I'm going to try to move really fast on this one, so you might have to pause me. Well, we're going to decompose the bottom number. So we're going to decompose 32. Well, 30 has 3 tens, 2 ones. Our other factor is going to go on top of the area model. I'm just going to represent this time the math problems. This time I'm actually not going to solve so that we can actually do it correctly. I'm going to rewrite this as unit form, 3 tens times 231. Now, up here, if we doubled 231, there's no regrouping I can see, so this should be 462. Well, let's go ahead and bring that over to the standard algorithm side, because first, now we have to do 2 times the top number, or the top factor. 2 times 1 is 2, 2 times 3 is 6, 2 times 2 is 4, 462. Well, those are perfect. Let's move on to 30 times 231, or 3 tens times 231. Well, 3 times 1 is 3. If you're doing this over on this area model to solve, there's no reason you should be not doing the area model or the standard algorithm. I'm sorry, because if you're doing that, look, that math that you just did right here in this spot is the exact math you're going to do over here, except you represent this first place with a 0 because we're talking about tens. Just like when we over here, we place that 0 at the end because we were talking about tens. Well, 3 times 1 is 3, 3 times 3 is 9, 3 times 2 is 6, already stacked and ready to add 7,392. I'm going to stack and add my partial products from the area model. 2, 9, 13, 7, 7,392. Great. Now let's go ahead and do one just with the standard algorithm, and then I'm going to unleash you to your problem set and exit ticket. 433 times, let's do 3. Oh, what? I didn't mean 3, 33. Perfect. 433 times 33. Now the first step in standard algorithm is to do the ones place. Well, 3 times 3 is 9, 3 times 3 is 9, and 3 times 4 is 12, right? The second step would be to go to the tens place, and this is the one where I think you have to be the most mindful, because you have to represent that 0 for the tens places. 3 times 3 is 9 again, 3 times 3 is 9, and 3 times 4 is 12. 9 plus 0 is 9, 9 plus 9 is 18, 2 plus 9, 11, plus 1 more, 12, 1 plus 2 is 3, plus 1 more is 4, 14,289. All right, so that's our math lesson for today. You are now going to shift into your problem set and then move on to your exit ticket. Nice job, guys.